Okay, so let's continue the video. Now, as you see, when I inserted my data in the last video in Power Query, I showed you how I did my data cleaning and everything. So after that, when I do close and load, I have all the data here. Like you see the GDP current USD, like everything I have here. Okay, so all the data inserted here properly. So this is physicians per 1,000 people, then life expectancy, population, age about 65, then there's like a demand score, then hospital bed per 1k people. Then this is the final demand score. Now how I have done the demand score, this is the most important part. So I've selected 6 data sets that can be like, for example, total population. Then there is average population, that's between 15 to 64. Then there is average physicians, right? Then there is average life expectancies. Then there is average age, like 65 above. And then there is average hospital beds. So these 6 data sets have got me a demand score. Now I'll show you exactly how I did it. Okay, so first, if you see, this is the population, this is the current population, that's a population of 2023. Okay, so what I've done is I've taken the minimum of this population, you see this minimum, and the maximum, you see this is the maximum, like there's a lot of maximum in that. So you see I have taken the minimum and the maximum of the population, the minimum population number and the maximum population number. Okay, then I have done a formula which is value, C2 is the value, minus minimum, that's Z2, divided by maximum minus minimum. So I've done that. Why I have done that? This basically converts variable measured in completely different unit onto a broadly common scale from 0 to 1. Okay, so you see, for every indicator I have identified the minimum and maximum values across the eligible countries. These values establish the lower and upper limits required for min max normalization, which I have done here. Okay, so sorting is useful for checking the result, but the minimum and maximum can also be calculated directed with min range and max range. Now, normalizing every indicator, why I've used this formula, that's value minus minimum divided by maximum minus minimum. So you see, for example, the population is measured in millions, life expectancy is measured in years, you can say, and physicians and hospital beds are measured per 1,000 people, right? As you can see. So adding those raw values directly would produce a misleading score because the larger numerical variables would dominate. So min-max normalization placed every indicator on the same comparable scale, allowing each one to contribute fairly. Now, a value closer to 0 represents the lower end of the data set, while 1 represents the upper end. Now you see, that's how I have used the normalization score. Okay, so I've used the normalization score so that because every data set is different. Now, since I want a demand score, so I had to have a certain formula, and that's how I've used the normalization formula, which actually gives us, value closer to 0, which actually represents the lower end of the data set, and value that represents 1, which represents the upper end of the data set. So that's how we get the normalized version of every data set. This is the normalized version of population. This is the normalized version of average population between 15 to 64. This is the normalized average of average physicians per 1000 people. Now you see the same formula I've used. That's value minus minimum divided by maximum minus minimum. Okay, so this formulas I have used to make the normalized scores. And once I've got all the normalized scores, now you see the formula which I have used. I have added all the six normalized value. Now why add six normalized value? Because each reference cell represents one of the six normalized demand indicators. Now you see I have added the values, six values, and divided by six. Now why divide by six? Because six indicators are being combined, right? So dividing by six calculates the arithmetic mean and gives each indicator equal weight. Now this result is an average normalized demand value. Now you see I have also multiplied it by 12 and added it by 1. Now why multiply it by 12? Because the average normalized value is usually between 0 to 1. So multiplying it by 12 expands the scale and makes difference between countries easier to read. And why add 1? Because adding 1 shifts the theoretical score upwards, producing a theoretical range of approximately 1 to 13 rather than 0 to 12. So after calculating the average of 6 normalized indicator, I have rescaled the result by multiplying it by 12 and adding 1. This has transformed the technical 0 to 1 result into a more readable business score with greater separation between countries. We should describe this as a custom rescaling choice, not a mandatory statistical standard. Okay? Now, that's how we have got the demand score. Okay? Moving on to the economic viability score for global MedHealth. Now, I have done the same thing here. Just I have taken three data sets for economic viability. That's GDP per capita. Okay. I've taken the minimum and the maximum, and then I've done the normalized score just like the same formula. Okay. Sorry, not here. It's here. So the same formula I have used. Then I have taken the average CHE per percent of the GDP and average CHE per capita. Okay. So all these things I've used, and I've all these three data sets. I've got the normalized version, and from that, as you can see in the economic viability score, I have done the same thing. Okay. So I have first added all three data sets, divided by 3. Okay, and into 12 till this, for demands till this, you can see economic viability score and demand score are absolutely equal, but I have added it plus 2. Now why add 2? Because it shifts the theoretical score from 0 to 12 to approximately 2 to 14. Now there is no universal statistical requirement to add 2 rather than 1. It is a custom offset selected in my model. And the safest professional explanation is like, you know, I rescaled the average normalized result by multiplying it to 12 and applying an offset of 2. This produced a more readable positive score and made difference between countries easier to interpret. So yeah, I had just experimented it because plus 1 I was not getting a proper economic viability score, so that's why I used 2. Okay, so we should not claim that this 2 has a special statistical meaning or something, because it's not. I've just experimented it and I've got a good economic viability score. Okay, so you can use 1 2, there's no problem in that. So that's how we have got the economic viability score, and as you can see, we have just made the final chart. How we have made the final chart? We have used the pivot tables. We have inserted the scores in you can say, insert, and here in the pivot table from table and range, we have inserted it, and that's how we have got the final chart. And from the final chart, we have inserted the data in the world map. where there are like map columns. Where's the map columns? Yeah, there. I click on it, and I insert the data of the demand score. I select that, and that's how we got the world map. And the same way we get this economic viability score. So this is of demand score, and this is of economic viability score. So I hope you understand this project well, because that's how we actually find out what is the demand score and economic viability score. So in the next video, we'll discuss how we got each like top 10 countries, how we, because obviously we got top countries for every data set according to their demand score and economic viability score. And yeah, that's how we have decided the top 3 countries which we are going to recommend to Global Med Health for the expansion. Okay, so moving on to the next video.